A few weeks ago, the U.S. Department of Energy named just two companies to share up to $40 million in federal money to commercialize the next leap in nuclear technology. One of them is a Berkeley, California company you may not have heard of yet, but if the nuclear renaissance is real, you will. They just broke ground in Texas. They report their first quarter as a public company in just a few days, and their CEO is on Advanced Nuclear today. This is the back end of the fuel cycle finally moving.
Welcome to Advanced Nuclear, the official podcast of UCAN Power, where leading experts, innovators, and policymakers explore the latest developments shaping the future of nuclear energy. Thanks to our sponsors of Advanced Nuclear, whose support helps make these discussions possible. ALO, energy without limits.
Welcome to Advanced Nuclear, the official podcast of UCAN Power, the United Coalition for Advanced Nuclear Power. I am your host, Dominique Cooper. If you've been paying attention to the back end of the nuclear fuel cycle, and if you're listening to this podcast, you probably have, you know the conventional wisdom that nuclear waste disposal in the U.S. is stuck. Yucca Mountain is on the shelf. $50 billion sits at the Federal Nuclear Waste Fund, and the country has been telling itself a story for 40 years that the problem is fundamentally political, unsolvable, and a future generations problem. Today's guest is very politely calling that story wrong. Rod Baltzer is president and CEO of Deep Isolation Nuclear, a Berkeley-based company commercializing a deep borehole disposal solution for high-level radioactive waste, using the same directional drilling technology the oil and gas industry has spent decades perfecting. Last month, the U.S. Department of Energy ARPA E program selected Deep Isolation as one of just two companies sharing up to $40 million in scale-up ready funding to bring the technology to commercial readiness. They've broken ground on a full-scale demonstration in Cameron, Texas. They are a public company now, and Rod also chairs the U.S. Nuclear Industry Council's back-end working group, which means when nuclear waste policy gets reshaped in this country, he's at the table. Now, I want to, before we get into it, I want to say that the views expressed by our guest are his own and do not represent those of UCAN Power or its member organizations. Rod, welcome to Advanced Nuclear.
Thanks, Dominic. I am excited to be here for the discussion today.
It's going to be fun. I am really excited. As I was sharing with you before we started the show, it's really awesome to do prep for our guest because I learned so much about the guest, and also I'm able to come up to speed on what various companies within the nuclear energy space is doing, and Deep Isolation is doing some amazing things. So I'm excited about our time. Are you ready to get into it?
Let's go.
All right. So Rod, you've spent 25 years in the radioactive waste industry. President, CEO, and CFO of Waste Control Specialist through its 2018 sale to JF Lehman and Company, then over to Deep Isolation as the COO in that same year and into the CEO seat in June of 2024. Could you walk us through the moment at WCS when you saw that the consolidated interim storage model wasn't going to be enough and Deep Isolation was where the back end was actually going to get solved?
Yeah, I think in the U.S., we've been focused on interim storage because the actual disposal was so hard and such a long time away. And so one of the reasons WCS started the Consolidated Interim Storage Project was to consolidate that, reduce those costs, and be able to move that waste. It was on track, I guess, when I exited, and as I moved to Deep Isolation, we could see that protest against that consolidation, against that transportation to that one site really took off, and the state politics kind of changed against that. And so, again, it's, not in my backyard. And one of the main questions they had was, well, how long is it going to be here? And they couldn't answer because there was no disposal facility. There's no policy to do anything, and the U.S.'s hands are just kind of handcuffed. And so it just kind of reinforces at Deep Isolation, we are trying to provide that final step, that final disposal, the ultimate thing you're going to do with it, and make sure that's safe and something that can happen in a lot of places, not just one place.
Oh, awesome. Awesome. So For our listeners who track the front end of advanced nuclear, we're talking reactor designs, fuel cycles, regulatory pathways, but maybe spend less time on the back end. In plain English, could you share what deep isolation is actually doing and why it's different from what the US has tried for the last 70 years?
Yeah, so deep isolation has taken directional drilling that's been perfected by oil and gas over the last couple of decades and used that to put spent nuclear fuel and high level waste deep in boreholes. And so when you look at a mined repository, this is an 18-foot tunnel that you can literally drive a train through. It's ventilated, you've got people underground, lots of engineered barriers. And it's about 500 meters deep. When you look at boreholes, we're about 22 inches in diameter, and we put one spent fuel assembly in a canister down in that well. But we'll be twice as deep. We'll be a kilometer or more deep. It could be up to 5 kilometers into a granite if you're doing vertical. And we can do vertical, slanted, horizontal, depending on your site needs and what that is. But it really opens up more geology. More sites are suitable the deeper you go. And it also allows you to co-locate this. It's modular. You don't have to invest everything into one mine. You could co-locate this with reprocessing facilities or nuclear reactors or other nuclear aspects, wherever that waste is currently stored.
Oh, that is fantastic. Look, guys, if you haven't, you have to go check out some of Deep Isolation's videos on YouTube where you get a chance to actually look at what their capability is. It's fascinating. So, Rod, on April 7th, you announced selection for the Department of Energy's ARPA E Scale Up Ready program, one of just 2 companies sharing up to $40 million in federal backing. You publicly called it the single biggest milestone in Deep Isolation's history. Could you tell our listeners what changes when Scale Up money lands?
This Scale Up program was made by ARPA E to take existing ARPA E contracts like our universal canister system and then commercialize that and make it ready for the market. Scale Up has a maximum award of $20 million, and we applied for the maximum grant. And so we were excited when we got announced that we were one of 2. And this is the first time ARPA E's ever made a Scale Up award to a nuclear company. So no other, reactors or anything got it. And we were the first. I think part of that is because we are benefiting the entire nuclear industry. At the end of the day, there will be waste to dispose of, and this is, something that is going to be needed to continue to progress nuclear energy. And so when that 20 million comes in, what that is for us is to fund our full scale end-to-end at-depth demonstration. And so we had announced in January that we were going to do a demonstration, but it was just the subsurface piece. This allows us to do the surface piece, so the shielded handling. How do you get that waste from the reactor or the transport to the wellhead? How does that connection happen? And then all the way underground at depth at full size. We also get to partner with Westinghouse and their Vinci reactor to make this demonstration specific for that, which is a TRISO-based fuel. We also are partnering with NAC International, and we'll get a certificate of compliance for that Westinghouse Vinci fuel in our universal canister system that can be in the Magna Store, which is above ground dry cask storage, or Magna Trans, which is a transport cask. So it really opens up a lot. And then, of course, we get the Department of Energy looking over our shoulder and making sure that we're doing everything that they think we should through the project.
Look, deep isolation. You guys are boots on the ground, right? You're doing a lot in Texas. So you broke ground at your deep borehole demonstration center in Texas. On the 28th of January, I think this year, and it's hosted at Halliburton's drilling technology facility. For our listeners, trying to create a picture as it relates to what's about to happen down there, what does the next 12 to 18 months look like physically on site, like actually in the dirt?
Yeah, so Cameron, Texas is about an hour and a half north of Austin, and we have been down there since 2018. We've been engaged with local communities and making sure they're up to date as we've done small scale tests, full scale at surface, and now getting ready to do the full scale at depth. and it is non-radioactive. We're not bringing radioactive materials in. This is surrogate material, same center of gravity and weight and things. But what's really nice is Halliburton has a testing facility there for oil and gas equipment. And so they've already drilled over 100 wells to test tools and equipment and techniques and things. And so we're being able to add a hole, basically a borehole to that facility and use that for our testing related to nuclear waste disposal. So what they would see if they walked out there during the groundbreaking, and we've got a groundbreaking video out on our YouTube channel, go check it out, but there is a rig already in place. And so it's got the mud pits and other ancillary equipment, training facilities and offices and a warehouse. But what we'll do new is build a new pad. So this will be near the fence line. And we've ordered casing, which is the long lead item. And then by early next year, we'll actually start physical drilling operations. Those will last about 2 months, and then we'll be able to place and retrieve canisters while we get ready for the surface handling aspect of that to continue.
Wow. I mean, all I hear is, great for the workforce there in Texas, potentially lots of job opportunities. So you completed the ARPA E Onwards project in Oklo in March, right? Where there was a validation of the borehole disposal for waste from electro-refining-based fuel recycling. For listeners who track the recycling debate, does deep isolation's existence change the political math on closed fuel cycles in the U.S.?
It's interesting. I don't know if it changes the recycling. I think that's happened regardless of boreholes, but it certainly helps. So what we've seen with Oklo, they'd like to reprocess fuel and then use it again in some of the reactor technologies. We've been working with them through ARPA E grants for several years now, and making sure that their waste is compatible with our universal canister system. And we've developed waste acceptance criteria and other things, and look at some of those evaluations, the cost and safety associated with it. And what we've seen is that, when you can co-locate boreholes with a reprocessing facility, you don't have any more transportation. That reprocessing facility reduces the volume, so you have fewer boreholes. And it also allows you to put that waste form in exactly what I need to put in my canister. And so they're very collaborative. And so it really works well in tandem to reduce the cost, any kind of transportation or shipping, reuse as much of the material as possible, and have that modular functionality of a borehole for that disposal for that last piece. That's a little more challenging since we don't have a mine repository program in the U.S. effectively. And so I think it's helpful to show that you can actually close that fuel cycle, and there's always going to be waste. One of the biggest misconceptions I hear is that, well, with reprocessing, there is no waste. You don't need a disposal program. But that's not true. We know there is some waste that comes out of that. It is a lesser volume. It's potentially a lesser hazard. But there is still things that need geologic disposal. And so adding boreholes to that to take care of that smaller waste just makes all the sense in the world.
Oh, it does. It does. So you chair the U.S. Nuclear Industry Council's back-end working group. U.S. NIC is pushing, among other things, for an independent waste management body outside of DOE. Could you make that case for our listeners? Like, why outside of DOE specifically?
Yes, spent nuclear fuel has, we've been wrestling with that problem for 70 years and really haven't made any progress here in the U.S. When you look at DOE, it is a massive organization. It has not only, the nuclear energy aspects, the environmental cleanup, it's got fossil fuels, it's got all these other things, thousands and thousands of employees, and it's got a lot of different things it needs to accomplish every day. And if you took the spent nuclear fuel disposal aspect of that out and put it into an organization that sole focus was find out how to dispose of it, I think it would make more progress. It'd certainly be more focused. And part of the other recommendations from US NIC, and we've got a paper on the US NIC website, if you look at the back-end working group page, is, provide consistent funding. Don't make it subject to the political changes in administration and things, but be able to provide consistent long-term planning, build up that trust that has sometimes been lacking, and some communities have people are not as trustworthy of the federal government as potentially science is what we're finding, I think. And so we're trying to be very factual and science-based, but if we can get that organization out and just focused on this one thing, we think that would make a huge difference there.
Rod, I mean, what a perfect segue into my next question. So, mile deep boreholes are by design out of sight. Beautiful thing. For some communities, that's a feature, right? It removes the protest target. But for others, it's a bug they want to see, monitor, and verify. How do you talk to a potential host community in 2026 that the federal government hasn't already alienated?
Yeah, boreholes do make a different conversation. So when, DOE's been trying to cite a mine repository or do something, back in the day, it was, we want to take all of the nation's waste, transport it to you, and dispose of it in one location. And so you were the one taking care of the entire nation's waste. And with boreholes, it really opens it up and it says, you don't have to take the whole nation's waste. It can just be your waste. And so it can be, your power plant or your facility, whatever that is. And you can control and kind of limit what goes in and what goes out. And so I think that's helps the conversation, because this is for people who probably already have waste in their backyard. When we looked around the U.S., there's roughly 80 nuclear power plant sites, and about 80% of those look like they probably had decent geology nearby. And so it really opens things up when you go deeper. That deeper geology opens up more opportunities. But when you ask about that trust, the other thing for the boreholes is they will be monitored. And it's amazing the technologies that oil and gas has. When we did our first test in 2018, it was a small 3-foot long canister that was about 5 inches. We put it in an existing oil and gas well and took it about 2,200 feet deep, 600 feet lateral, and let it go. Brought everything back, showed no cables attached, and went back and retrieved it and pulled it back up. And everybody in oil and gas said, that is the dumbest test we've ever seen. We do that all day long. I mean, that's what we do. We deploy tools downhole and bring them back. I mean, what are you guys thinking? And everybody in nuclear was like, that's the best test ever. I had no idea you could retrieve things out of a borehole. And so it really is, things that they do in oil and gas, we don't really know in nuclear, and vice versa. And so we're connecting those two, industries and all the technology and the things they do. And the safety. Both of them are very focused on safety as well. But when we look down, there are ways to monitor that, whether that's through wires that are attached to the actual casing, monitoring wells that are adjacent to that. You can measure temperature, pressure, radiation. You can measure different aspects that you're interested in, and get that real-time monitoring. That can even go through, blockchain and other things to make that irrefutable source of knowledge there.
Wow. So I like to ask this question because for me, and I think also for some of our listeners, it helps to really understand the big why. So let's transition into, if deep isolation did not exist, if you and Halliburton, Westinghouse, Amentum, NAC International, if you guys weren't doing this work, what's the realistic baseline scenario for the U.S. spent fuel disposal in 2040? Could you walk us through the world where this does not happen?
Yeah, 2040, 2050, there is no disposal program. Deep isolation is the only, boreholes are the only thing that would allow us to move that fast here in the U.S. So when before deep isolation came along, the plan was that maybe we could get a site and start disposal in a mine repository in the 2070s. And so that's a pretty long way away. And then that would need to operate for 100 years. And so, I mean, you're talking multiple generations way out there. And we're even seeing, we're a global company. And so we see in Europe that there's a taxonomy, and it said that if you want green bond financing for your new nuclear projects, which would be very helpful, then you have to have an operational disposal facility by 2050. And the only way to do that is boreholes. And so we've gotten letters from a couple of different countries who have said, we're interested in this because that's the way we can meet the EU taxonomy law. And so it's great to see that, we get it. When we drill a borehole, it's about 2 months. When Finland, which is the closest mine repository to opening, they should open this year. But it took them a decade to build the mine repository for just the construction, not the siting and all the licensing, but just the construction. And so it's a huge difference when you do boreholes. And we're smaller. We got a lot more boreholes than one mine repository, but it is something where we're a lot nimbler. We can be faster, and we can also tailor this to whatever the community, state, or whatnot is interested in.
So This wasn't on my list of questions, but and we don't really have to get into it, but I'm curious as to why it took nearly a decade to build out the mine repository, right? Like that is,
Yeah.
I mean, and in all fairness, I am not well versed in that area, but like when you think about what you guys are doing in comparison to the time frame that it takes to build that repository, oh my gosh, right? Like that's I would say life changing in the world of nuclear waste disposal.
Well, when you look at a mine repository, this is something where you kind of have to construct the whole thing before you start putting waste in there. And so once you have radioactive waste, high level waste down there, you don't want humans under there managing a construction project or anything. And so as you figure out how big that mine needs to be, you need to then construct it. You have to put ventilation. You've got your engineering supports. You've got different, holes, I guess, that you're putting the canisters in. You're developing those canisters, which are typically copper because they rely on that canister as one of their engineered barriers for a longer period of time. And then you've got to figure out all your sealing mechanisms because you've dried out this mine that probably was wet when it began. And now you got to keep it dry and keep it that way. And so there's just a lot of engineering and other things that go into that process. When you look at boreholes, we're going to be in a wet environment. When we drill, we use a drilling fluid to keep that hole pressurized. So it's not overpressurized. We don't fracture the formation. It's not underpressurized. We don't collapse and create potentially a stuck canister or anything, but keep it there. And when we're done drilling and we've cased it and we put cement in it, then we've got a nice firm barrier, but we've got an emplacement fluid. And we could put corrosion inhibitors if we wanted in there. But there's really no oxygen. We haven't ventilated it down. And so it's a reducing environment, which is less corrosion, and we're less reliant on that for our canisters and other things. So it's just a lot of benefits for being deeper.
Oh yeah, guys. I mean, if you are as fascinated as I am, you have to go check out their videos on YouTube. And I promise Rod did not twist my arm to say that. They are doing some amazing things.
Thank you.
So, Rod, what's your personal why? You have done your resume, is a testament to a lot of fantastic and incredible things that you've done. What's your personal why?
I stumbled into nuclear waste. This was not something I intended on. I was an accountant and looking for a job and stumbled into it. And it's fascinating. I had no idea this industry existed. And the more you learn about it, and the more you kind of get into it, it is making a difference. You're cleaning up sites. You're putting things where they need to be. You're not kicking the can down to the next generation. And so it's, it does feel good to make a difference. And it's something that's been needed to be done for a really long time. So, it's been fun. Everywhere I've been, I mean, nuclear industry is so great. The teams you get to work with, the employees we've got, just couldn't happen by myself for sure. It's been the teams, and it's been tremendous. Love it.
Oh, that's awesome. That's awesome to hear. So, thank you. I appreciate your time. And before we close out, I want to pass the mic to you for closing remarks.
Yeah, I appreciate it. I love doing these conversations. A lot of people don't understand the back end and how important it is. In the U.S., we all as taxpayer are paying about $2 billion a year for penalties for storage of waste. It's not ratepayers, it's us as taxpayers. And I don't think there's, enough interest. There hasn't been. But I think recently it's really opened up. There's been a discussion. There seems to be movement toward it. It's probably the most exciting I've seen in the back end anyway for decades. So I'm really encouraged with where we're at, where we're going as a nation right now for the back end policy, and really hope to make a lot of progress over the next couple of years. So stay tuned.
Rod, you and your team are doing something this country has been told for 40 years is impossible. And you're doing it not by inventing new physics, but by treating the back end of the fuel cycle the way good engineers treat any other industrial problem, with known geology, with proven drilling, with a regulatory ready canister, and with patience to do the demonstration before the deployment. May 14th, you have your first earnings call as a public company. The next 12 months are going to tell us a lot. Thank you again for being on Advanced Nuclear. And for our listeners, the back end of the fuel cycle is no longer an excuse, not for delaying advanced reactor deployment, not for blocking host community engagement, not for parking spent fuel at orphan sites for another generation. If you work in the nuclear policy, defense, industry, or capital allocation, pick one bottleneck on the back end you can personally help unstick this year. That's how we're going to get to a real nuclear future. UCAN Power exists to accelerate that conversation. Visit ucanpower.org to learn more. Thanks for listening to Advanced Nuclear. I am Dominique Cooper. See you next time. Thanks for joining us on Advanced Nuclear, powered by UCAN Power. If this episode brought clarity to the future of American energy, share it with someone shaping policy or industry. I'm Dominique Cooper. This is the moment. This is the movement. See you on the next episode.
Building education for energy. B, activates communities, educates the next generation, and makes energy careers visible, real, and worth chasing. Learn more at bcamp.org.